Okay, today we're talking about simplifying and evaluating algebraic expressions. And the first problem we're going to talk about is problem number 3. First thing you need to think about is when you're evaluating and simplifying expressions is when you have a fraction, which is a rational expression like we have here, is the numerator simplified completely and is the denominator simplified completely. So if I look at this and I say x squared is as simplified as I can possibly go. However, the bottom is not. So I keep the numerator at the top the same, and the bottom, I'm going to see if I can factor this. So can I factor anything out of this? What they have in common is an x, so if I pull that out, I'm left with x cubed minus 1. Now, look at this and say, is there anything in the top and the bottom that's in common? Well, you're going to cross cancel. There's one x in the bottom, and there's 2 at the top, so I'm going to be left with an x over an x cubed minus 1. This is your new f of x. I cannot cancel off this x in the numerator with the x cubed at the bottom because that head and the body is attached together. The x cubed and 1 are attached by subtraction, so they stay there. This is your simplified expression, and then the rest of the instructions say to do f at 0. So once I'm done simplifying, I'm going to go ahead and do f at 0. So every place I see an x, I plug in 0. So 0 divided by -1 gives me 0. So therefore, my answer here is going to be f at 0. This is going to be 0, so that gives me the order pair 0, 0. Pretty simple. Let's go to number 4. Number 4. This says, can I simplify this any further? Well, if you look at number 4, I could simplify this further. I could go ahead and FOIL that if I wanted to. But is it really going to get me any further? Okay? For those of you who need to remember how to FOIL, you can do x squared times x, which gives me x cubed minus 4x. And it gives me 3x squared minus 12. This gives you x cubed plus 3x squared minus 4x minus 12. I would accept this, but I would also accept this. They're the same. Another thing I would accept is the x plus 3 times, going ahead and breaking down x squared minus 4. That's x and x. I need a -4, so that's plus and minus. Factors of 4, that gives me 0, 2, and 2. This is another simplified form. All 3 of those boxes are equivalent, and they're going to get you exactly the same answer. So I would accept any of those. And the last part of it says to do f at 0. So I'm going to take the original one, 0 plus 3, times 0 squared minus 4. This gives me a 3. This gives me a -4. This gives me a -12. So with that said, f at 0 equals -12. Give me the order pair 0, -12. Again, pretty simple. Okay? The next one is number 5 that I'm going to talk about. Number 5 says I need to go ahead and I need to simplify what's underneath the radical. Now, if I simplify this, x squared minus 16 is the head of the body. You cannot take and write this as x minus 4. That is illegal, 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 illegal. You cannot do that. What this actually is x. And x. I need a -16, so that's plus and minus. Positive 4 and a -4. All over 2 times the jump. I cannot factor x squared plus 1 into 2 binomials because this is a plus 1, which means it's plus plus or minus minus. That's going to give me a -2 or a +2 on the inner and outer, and I cannot do that. So this is already in its simplified form. I cannot do anything with that. This blue part that I have here, it didn't help me. So what I need to go ahead and do is I need to go ahead and start out with my f at 0. So I'm going to go ahead and plug in 0 squared minus 16, 0 squared plus 1. So that's going to give me the square root of -16 over 2 times the 1. What's the square root of -16? Well, if you remember right, that's going to give you -1 times 16 all over 2. Well, -1 underneath the square root is I squared. To give you the square root of I squared comes out as an I. The square root of 16 comes out as a 4 to give you plus or minus 4I over 2 to give you plus or minus 2I. In other words, this is not in the real number system. It's in the imaginary number system. So therefore, f at 0 is equal to plus or minus 2I to give you the ordered pair 0 plus or minus 2I. So if I ask for the real numbers, you would say that there is undefined there. In the imaginary number system, this is your answer. In the real number system, f at 0 is undefined. Okay? So this is going to be in the real number system. Okay? Now the last one I'm going to talk about is number 10. And again, we're going to treat number 10 just like you would treat number 3. So if you're looking at number 10, if I have 9x squared plus 3x, can I factor 9x squared plus 3x? The answer to that is yes. I can pull out a 3 out of the 9 and the 3, and I can pull out an x. So that gives me 9x squared divided by 3x gives me 3x. 3x divided by 3x is going to be 1. All over 12x cubed. Now what's in common between the 3 and the 12? 3 becomes a 1, 12 becomes a 4. The x goes away, becomes a 1. The x cubed becomes an x squared. So I'm left with 3x plus 1, 10 bodies, over 4x squared. This is f of x. And that's the simplified form. Again, the 3x is attached to 1. You cannot cancel that out with the 4x squared bottom. So now I need to do f at 0. So that's going to give me 3 times 0 plus 1, or 4 times 0 squared. That's going to be 0 plus 1 over 0. Give you 1 over 0, which gives you an undefined. Why? Because you cannot divide by 0. So f at 0 is undefined. Okay, so for homework, you have to finish this worksheet, and then remember, tomorrow we will go over it in class together. Have a great day, guys.